Welcome to the last podcast of the entire semester. We made it, and we're talking about urine. All right, diuresis is the production of urine, but it sounds a lot nicer than saying production of urine. Urine is 96% water and 4% ions. And when we talk about ions being excreted through urine, we're talking about sodium ions, chlorine ions, calcium ions, as well as bicarbonate ions. Waste, or urea, is also excreted through urine. We talked about this when we talked about protein metabolism. And we talked about how amino acids are broken down to produce urea. pH of urine can also vary very widely. Poorly worded sentence. It can go anywhere from 4.6, so a little bit acidic, to 8.0, a little bit basic, and it is affected by the food that you take in. If you're eating a lot of fruits and vegetables, your urine's going to be more basic, versus if you're eating a lot of protein, your urine is going to be more acidic. Your kidneys will filter through 100 liters of blood per day normally, and only 1.5 liters of that is excreted as urine. All right, so our blood gets filtered through our kidneys, and your filtrate is going to enter your glomerulus in the Bowman's capsule, and it'll eventually go through this entire yellow structure, your loop of Henle. The descending loop of Henle is where we reclaim water, and your ascending loop of Henle is where we reclaim ions. So in previous podcasts, we talked about that fluid and electrolyte balance, and this is where the rubber hits the road. This is where we reclaim the water so that we don't lose a bunch of water and have to take in a bunch of water, and this is where we reclaim those ions to maintain a balance. If we have excess ions, those are going to remain in your filtrate and eventually become urine. Eventually, though, our filtrate is going to wind up in the collecting duct where it will be excreted. So keep in mind, besides water and then salt ions like sodium, potassium, and chlorine being reclaimed by the body is also going to reclaim glucose. Now, if you have a metabolic disorder such as diabetes, your body's going to have an excess of glucose that it cannot convert to glycogen, and so you're going to wind up getting rid of some of that glucose in your urine, and that would be a good test for us to test the urine to see the presence of glucose. We can find out if we have an undiagnosed or an uncontrolled metabolic disorder. I like this visual of input and output each day. So your average intake per day, 10% is actually made up from metabolism. So one of the byproducts of cellular respiration is a certain amount of water. In humans, we don't get a lot of water from cellular respiration, but there are some organisms such as the kangaroo rat, which is found in hot, arid, and dry Australia, who gets a majority of their water from cellular respiration because water is scarce. I kind of wish we were like the kangaroo rat. You get 30% of your water from food, but 60% of your daily intake of fluids is going to come from beverages. So again, we said the average adult is shooting for about 2,500 milliliters in and 2,500 milliliters out. 4% of your liquid that goes out of your body is going to be in feces. 8% is sweated out. 200 milliliters each day is sweated out. Now, I don't think that takes into account the time of year. This is just an average. 28% of water is lost through your skin and lungs, and 60%, a majority of your fluid, is going to be excreted in the form of urine. It wouldn't be a talk on urine and kidneys if we didn't talk about vasopressin, which is a hormone that controls your kidneys' absorption of water. It's also called an antidiuretic hormone, or ADH, and it increases the amount of water retained and decreases the amount of urine input when you have higher concentrations of solute in the body. So if you remember back from our discussion in last semester on osmosis and dialysis, if you have a high concentration of solute outside of the cell, that is where water is going to go. So when you have those higher concentrations, you need this hormone so that you can retain some water as that solute concentration increases so that you can maintain your homeostasis and your fluid and electrolyte balance. If you were to take in a diuretic, that's going to decrease your blood volume and your sodium ion concentration. It will increase urine excretion. So diuretics are things like coffee and soda. These are essentially increasing the solute in your body. They're also going to increase your output of urine. They work against antidiuretic hormones. When you are excreting a large amount of urine, it's also going to lower your blood pressure because remember that blood is mostly made from water. So if you are outputting a lot of water in the form of urine, that's going to lower your blood pressure as well. However, if you're retaining a lot of water because you've taken in a lot of solutes, that's going to increase your blood volume because it's increasing the water, which will therefore increase your blood pressure. So that's why people who have high blood pressure are advised to avoid intaking a lot of salt because that's going to increase their solute concentrations as well and increase that water that's retained. All right, so as we kind of alluded to and we've talked about a little bit in class already, if you have abnormal amounts of glucose in your urine or ketones or proteins, these are all indicators of pathological conditions. So we can do a quick urine analysis and find out, do you have above high concentrations of solutes or sugars or proteins, and we can start, doctors can then take that from there and start to diagnose and get those metabolic conditions in control. So some abnormal concentrations are named with prefixes, and this makes them really easy to figure out. If you have something that is hypo, that's under normal conditions. If you have something that's hyper, that is above normal conditions or your normal threshold for those ions or glucose amounts. Emia refers to in the blood. And then we can also refer to ion concentrations. Our most important are sodium and potassium. So Nat for sodium, which comes from natrium, which is where we get that symbol in the periodic table, and Cal for potassium. Again, that's where we get the symbol from the periodic table. So if we were to put these all together, we can kind of figure out what's going on with a person. So if I said I had hyponatremia, I have low sodium in the blood. We can break apart those words and give a good descriptor. Hyperkalemia would be high potassium in the blood. And so doctors can use this information to then treat people who have these conditions.